Now that we have the basic idea of hypothesis testing, let's look at actually performing a hypothesis test. So there's going to be three main steps. Step one is going to be to state your hypotheses. So we need to actually figure out exactly what H0 is and exactly what HA is. The next thing is to actually calculate the p-value. And there's going to be several different ways to do that. For now, we're going to restrict ourselves to testing a mean, and in particular with a known standard deviation, just like we looked at for confidence intervals. So our command will be z_mean_test. We'll need the sample mean, population standard deviation, sample size. This H0 is exactly what your hypothesis is claiming. What is your null hypothesis claiming that it's equal to? And then the tail is going to be your less than, greater than, or not equal to, whatever the alternative hypothesis says. And then finally, we make a conclusion. And just a reminder, if our value that we calculate in step 2 is smaller than alpha, then we say HA is true. So let's look at some examples. In Pennsylvania, the mean IQ score is 101.5. We know this is normally distributed with a population standard deviation of 15. A school is claiming that their students are above average. And a sample of 30 students at this school has a mean IQ of 106.4. So we want to test this claim at alpha equal to 0.05. Our first step is to state our hypotheses. We know that the actual mean is 101.5, so that tells us what our null hypothesis is. For our alternative hypothesis, we're claiming that these students are above average, so they should be greater than 101.5. For the next step, we need our calculator command, which is z_mean_test. The first thing we need for this command is our sample mean, x bar. And we know that we see that the students have a mean IQ of 106.4, so that would be our sample mean. The next thing we need is population standard deviation, which we can see in this problem is 15. We then need sample size, which in this case is 30. The next thing to enter is H0, so that's wanting to know what H0 is equal to, in this case 101.5. And finally, we need to enter the tail. And the tail is going to be either less than, greater than, or not equal to. In this case, our alternative hypothesis was greater than, so it will be greater than. And whenever we input the tail, we need to put it between quotation marks like this. Now that we have this, let's go to our graphing calculator. Here's the GeoGebra graphing calculator. We'll click the three dots to get to the menu, down to statistics, and to the very bottom to the z_mean_test. We then need our sample mean, 106.4, comma, standard deviation is 15, sample size is 30, our null and alternative hypothesis were 101.5, and then we need our greater than symbol. And at the top here, you have this ABC. We're going to click on that. This symbol down in the bottom left corner will get me to my quotation marks. We then can go back to the 1, 2, 3 to enter the greater than symbol and enter. So you'll notice this gives us two values. The first value is the p-value that we need, and the second value is the test statistic. So in this case, our p-value is 0.037. We now need to test that with alpha. So we need to compare if this is greater than or less than alpha. And we can see that this is smaller than 0.05, which is our value for alpha. And so if our p-value is smaller than alpha, then we say H0 is false. If H0 is false, then we know that HA is true. So yes, these students are above average. They are greater than 101.5. We know that the average rehabilitation cost for stroke victims is $24,672. A researcher wanted to know if the average cost is different at a particular hospital. A sample of 35 patients had an average cost of $26,343, and the population standard deviation is 3,251. At alpha equal to 0.01, can it be concluded that this hospital is different? So let's start with our hypotheses. We know that the average cost is $24,672, so that would be our null hypothesis. The researcher is not claiming that this hospital is above or below average, just that it's different. So HA would be not equal to. Now that we have that, we can start building our command for our calculator. We have z_mean_test. We have z_mean_test. We know that the sample mean of these 35 patients is 26,343. We know that the population standard deviation is 3,251. The sample size is 35 patients. The next thing we need is age 0, which is that 24,672. And then the final thing we need is our tail, which in this case is not equal to. And once again, we need to put that in quotation marks. So let's go over to our calculator so we can type this in. Here's our calculator. I'll start by hitting the 3 dots and selecting z-mean test. We then have our sample mean, 26,343, comma, our standard deviation, 3251, comma, sample size of 35, our hypothesis, 24,672, and then finally our tail. We go over to the ABC and then the symbols. We can click the quotation marks and the not equal to symbol. And we have that our p-value is 0.002. We once again need to compare that to alpha, which is 0.01. And since our p-value is less than alpha, we know that H0 is false, so HA must be true. And yes, this hospital is different.